Hello, everyone. Welcome back to part 3 of the Decentralized Stock Exchange series. And, guys, I've been trying to post this video for the past 2 days. Well, actually, 3 days. So, what had happened, I got busy dealing with some new technologies and business. As I told you, I run my own business on the side, and I just got completely busy. I was supposed to have this done last night and post it today, but I forgot to save, so that took a lot out of me, and I was very stressed out when it happened. None of the matter, we will furthermore persist, and I'll just go over what I was going to talk about. So I was actually going to go over this script, the token Solidity script, and the test script, but it came out to be almost 30 minutes long, and I did not like that. Now, what I'm going to do, I'm just going to go speed through everything and talking about the different components, why I added certain things here or there, and just give you an overall introduction to the Solidity programming language, because this is one that we are going to be using for the series and for other blockchain projects that come in the near future. Not only that, Solidity is also one of the more prominent contracts out there. No, Solidity is one of the most prominent coding languages out there for the Ethereum coding language, and it's one that is very similar. It has similarities from JavaScript, Java, and C. So if you're familiar with any of those, then you should pick up Solidity fairly swiftly. So this right off the back, we have Pragma Solidity, and this is the version number. So we're using version 0.5.0, and this caret just basically means, I guess, the latest stable version of it, and any version above it should also work with this script. So Ethereum is also in its early stages. I know that it's a complete cryptocurrency project, but what has been told in the community that Ethereum 2.0, when that comes out, is essentially going to be considered the very first stable version of Ethereum, because what we have now is Vitalik's prototype, but now what we're going to have is going to be what Ethereum 1.0 should have been, but none of the matter. I'm excited for that. So here I'm importing the OpenZeppelin library, which OpenZeppelin is a fantastic project if you need any help in enhancing your smart contract code, or just want to learn about how to program dApps. They have great documentation about all that stuff. This contract, you can almost consider this as a class. So when this contract gets deployed to the blockchain and changes, and when you go into testing it and calling this contract in other languages for different scripting, then this is what you're going to be called right here. And it just makes all the more sense to have the file name the same as the contract name. So using safe math for uint, group are importing this from the OpenZeppelin library to handle math functions a little bit better. Oh, and you can also see another thing. Well, the stable, something that is supposed to be stable for Solidity, is having these semicolons. So you make sure you have all these semicolons in your code at the end of every single line. And don't worry, Solidity will scream at you just like Java will do if you don't have these semicolons. They are mandatory and not optional. So here, just like any other programming language, we have the data types, string, and uint 256. So uint basically is an unsigned integer. So if you didn't have this u here, then this number could be a positive or a negative, but the uint means it's unsigned, so all numbers must be a positive whole number. So that's what the uint comes from. And the 256 is just the data type. You can figure out how high your number can get just by using binary and getting the decimal of that. Public public is a keyword that means this these variables could be read from outside the contract. So when we go and code these smart contracts, we want some things to be read from different scripts, especially when we go in testing. And I'm not gonna have testing in this video. I'll put it into the next video. So all these variables are public, meaning so when we run tests in our JavaScript file, then it will be able to read these variables. Things you see in the cyan color are keywords. The red you'll see are data types, and white is mostly consisting of variable names. And what you see here, this light blue color, it's going to be just strings. So I named it Decentralized Atlanta Stock Exchange, just a nod off of the New York Stock Exchange. And here's just the symbol for that. And I'm creating this smart contract more as a basis for when we go and tokenize all these other stocks. It'll just simplify the process, and we don't have to, create different ones for different stocks. And when we go to deploy this, we are going to deploy it on the testnet. I'm going to figure out, because and the reason I'm going to deploy it to testnet is that the SEC has a lot of regulations in terms of ICOs, and they've been really cracking down on blockchain technology. So I'm going to figure out whether, if this was going to become a live project, what I need to do. For that, I'm very familiar with business and certain legal aspects. So if it ever becomes essentially a live project, then I'll let you all know, and you all be a part of the journey. So decimals, this is the smallest dominion of this token. 18 is essentially the default one for Ethereum, because the smallest unit of Ethereum is Wei, and is 18 decimal places. Total supply is essentially the total supply of the tokens that this token has. Like Bitcoin has 21 million Bitcoin. Ethereum doesn't have a total supply. I think Ripple is at 100 billion. So that's what the total supply is. Mapping, you can almost relate it to objects, or if you're from Python, like dictionaries, you have a key pair that's connected to a value, and then here this public again is reading. This public variable is going to be able to read outside of this contract and the balance of. So this is going to get the balance of this address. And this address is a data type. So in Solidity's addresses, meaning the wallets you send to in Ethereum, these addresses will be data types. And obviously it's going to return a number. This address is allowance. So here we are going to allow the exchange to allow certain users to withdraw certain amounts and be able to spend. So we are basically giving this exchange permission, but we don't want the exchange to spend all the money or all the tokens that we have, but only a certain amount at a given time. Event transfers. So on a blockchain, the blockchain is essentially a stack of logs, and so now we have events, and what events are. So the blockchain consists of blocks and transactions, which consist of logs, and these logs have a record of events that take place from certain smart contracts, and these are what these events do. They essentially log events to the blockchain. And we have a transfer event that is main purpose is to facilitate the transfer of funds from one user to another, depending on the value of the balance. And we have an approval function where we're allowing the owner, in this case the exchange, to allow the spender to spend a certain amount. This constructor, this is a function that runs on deployment. It's basically stating, okay, so here we are stating that we are setting this total supply to 720,000 ether. This right here So in Solidity, everything, all the in Solidity, all the balances are recorded by way, and you have to essentially have 18 decimal places to equate to 1 ether. The ether helps for human readable code. So I have this function here that's basically a scientific notation that we are getting 10 to the power of 18, and we're going to multiply that onto 77,200,000 700 and 200 720,000 to get a ridiculous number. This balance of, we are setting the message.sender, which is essentially the deployer or us, to have this amount of tokens. This is how cryptocurrencies get minted. There's no special amount. Whenever you create a cryptocurrency, you can set however many tokens you want it to have, and that's the beauty of it. But if you do set a limit, and if you have an ERC20 token, you have to set a limit, then this is how you do it. Down here, we have our functions. So if you're familiar with other languages, functions are essentially methods that does something. Here we have stated transfer name, and we are passing in. So this function, sole purpose is to transfer the funds, while here this event is to process that event on the blockchain, and I'll get to that in a minute. This address, we are passing in the to address, and we are going to pass in the value of the balance because we want to allow users to send funds on our exchange. Public, we are having this function be read outside of the smart contract, and returns, meaning this is the type that's going to return. We have to have these modifiers to let the function know what it's going to return. And we are going to return a boolean, and the boolean, this is just the local variable, and we are going to state boolean to return a certain value. This require similar to conditionals like if statements, things of that sort, but they are a little different because this comes first in the function, and if this, well, here we put it first, but we are basically stating here that if the balance of the sender or whoever is sending from is greater than or equal to the value, then we can proceed. And then we also have an internal function, which because we had a lot of code here that we had to duplicate, but here we are just shortening it. But in this case, we are going to be senders, so that's why we put this here, but this is only for testing purposes. But obviously once it gets deployed, we're going to have other users send funds back and forth to other users as well. But we are allowing this so that way we can push funds into the market. Now we have function underscore transfer is essentially a shortened version of what we're going to have here, but being able to duplicate it. We're going to pass in the address we're sending from, and we're going to have an address we are going to be sending to, all while stating the value here. And this is why we have the internal, so that way we don't want this function to be read outside the smart contract. We just want this to be accessed within our little bubble token Solidity smart contract that we have here. Again, we are stating that the address we're sending to is a valid address. So this is what this means. So if the value of the address is not a 0x address, then no tokens are allowed to be sent to this. And then we are stating the balance. So here we are saying the balance of the address we're sending from, we are going to deduct the value, because when you send funds on the blockchain, you aren't really sending funds per se, but what the code is doing is stating, okay, this person has authorized that and confirmed that it would like to send X amount of funds to this user, so we are going to deduct that amount from the user's balance, and we are going to add that to the user we are sending to, which is here. So here we are deducting that amount, and where you see the sub function, that comes from safemath.uint, because it's not a function that's already in the Solidity programming language. And now here, so once we subtract that amount, we instantly add that same amount of value that we took from what we're sending to, and we are going to be adding that to the balance of the user we're sending to. Okay, and then now this is all great and all. So now it comes down to committing this event to the blockchain, and that's what this transfer event does. It emits this transaction, so it logs this event, and now it'll be out there for the whole public to see. Now, this approve function, where I state where we are going to be allowing the exchange to, send funds or process funds for us on the through the smart contract on the blockchain. So we have an address, the spender. Again, all these values and underscore sender underscore value are local variables, meaning they're only going to be accessed within this function. Public, it can be accessed outside of this contract. It is going to return a true false statement or a boolean. And then down here, again, making sure the spender is a valid address, and we are allowing, and whatever the sender is allowing the spender, we are equating the value, meaning we are allowing the exchange this amount of value to be able to, process, and then we are emitting that approval on the blockchain. Again, same thing. Now, the transfer from function is allowing users to send funds to other users, whereas up here, the deployer or the smart contract was only sending funds to users. This one is more of a peer-to-peer. So we have the address that's going to be sent from, and we're going to have the address that's going to be sent to with the associated value. We are requiring that the value that the funds we're sending from has enough funds that the value that they're sending doesn't go above what they don't have, because we don't want in the banking world, this is essentially what the code that we will use to stop an overdraft. But banks don't have this, because that's why you get hit with overdraft fees if you overcharge on a credit card or debit card. If they have this would save a lot of people more money, but banks like to make money, so they don't have this. But in crypto world, we have this, so you can't spend phantom coins. You got to have the right amount of coins in order to spend those coins. Now we have require, where we are allowing the address we're sending from on the exchange to be able to send that amount. So if they have the associated amount, then they'll also be able to send, making sure that what they are sending isn't more than what they aren't allowed. And from here, the allowance of the address that's coming from, we are going to deduct that from the value that's being passed in. And then this is why we have that underscore transfer function, because we just repeat the process all over again. And that is essentially the start of the Solidity programming language. I wanted more content for this video, but I have a lot to do, and this is one of many things I did over the past 5 days in terms of the project. A lot of times I was just testing, but I'll get to more of that into the next video that will be out even sooner than this was supposed to be. So I'm going to get back on track in the video postings, and I'm also going to add more content too. I have a lot of content in terms of tech that I'm going to be focused on right now. All 2020 be focused morely on the blockchain. I haven't thought about diving other tech, but I can go into how blockchain impacts other technologies. I feel like that's not really something that's talked about a lot But you guys let me know what you want me to talk about, and as I, advance, I'll get better equipment, and things will get a lot better as well. Lastly, if you want to support me further, you could get yourself some nice crypto ray glasses at my startup on streamline.co. I'll have that in the description as well. So I hope you all have a fantastic day and happy coding as always.